This is the first talk in our series Control Systems 101. In this series of talks, our aim is to demystify control systems and make it more accessible to engineers who either were confused by it in university or who never actually took a control systems course. In talk number 1, I am going to give firstly a very short history of control systems. Then I shall also mention why control systems are so important in today's industry. And I shall give one example of a single mistake in a control loop design that cost a company something in the region of $100 million over 13 years. The first record we have of an automatic control system was in about 300 BC, when the Greeks used a level control for a water cistern. Water cisterns have been a vital infrastructure for thousands of years, and medieval castles all have large water cisterns down in the basement. Nowadays the same technique is used for toilet flush cisterns. There is also a record of a room temperature regulator for wood-fired heaters in Holland in 1572, but I know very little more than that. In the pioneering days of steam, the British invented a steam boiler pressure regulator in about 1681. And if you know anything about steam boiler explosions, you will realise how vitally important a pressure regulator is. The most famous first use of full feedback control was James Watt's flyball governor, which he patented in 1769. It was used for controlling steam engine speed, and the steam engines were essential for powering early mills such as textile mills and flour mills. It was sometime later when steam engines were then used for locomotives. Billions of dollars are lost from industry every year because their control systems are not working properly. This is a hidden loss because so few people have the skills to even recognise the problems. Hopefully, our Control Systems 101 talks will help alleviate the issue, and we shall be presenting a range of examples of real-world problems. I'm going to talk about one such problem now. The gold mine was producing about 670,000 ounces of gold per year, and they were losing 3.5% of gold to tailings. Now the reason for that was that they were using the wrong algorithm. So what I did was, and everybody on the site was blaming a particular measuring instrument, and I wasn't sure that that was the case. In fact, I was certain it wasn't the case. And so I accompanied the instrument technicians on their daily routine to calibrate and clean the particular measuring instrument. I assisted them with that job, and in fact I was satisfied that they were doing it correctly, and I was perfectly satisfied that the instrument was 100% spot on. So it wasn't the measuring instrument, and so I had a good look at the process, and I was amazed to find that they were actually using a PID control algorithm. Totally inappropriate. They should not have been using a PID control algorithm in that particular role, and I was able to determine very, very quickly that in fact it was the PID controller that was causing all the trouble. I will probably discuss that as an example later in the course. So I got rid of it. I ripped it out and I replaced the PID controller with a feed forward control design. It took me about 50 hours of work to design the new controller, to do all the investigation work I had to do, to program it up and to install it, get it working properly. What happened was that the 3.5% of lost gold went straight down to zero. They couldn't measure it. The process engineer came to me the next day, a day or two later, and basically said, Paul, the lab can't measure it to tailings. That's amazing. And so the saving, the gold was worth about $425 per ounce at the time. I should have bought some. And the loss in that year was about $11.5 million. Over the 13 years, the loss was about 100 million. Just because somebody had installed the PID control algorithm when they should have designed something else. So welcome to Control Systems 101 from Paul and Dave, and we hope you will join us again for talk number 2, which is on closed loop control. The engineers in control are Dr. Paul Wilson and David Clement. You can find out more about us at www.engineersincontrol.com. Unless explicitly stated, all content in this video is original and is copyright 2021 by Dr. Paul Wilson and David Clement. All rights reserved.